In resonance, there are 3 legal moves. So these are the legal moves of resonance. The first is that you can move a lone pair to become a pi bond. Another is that you could move a pi bond and turn it into a lone pair. Finally, you could take a pi bond and turn it into another pi bond. What you can't do, though, is turn a lone pair into a lone pair. So let's see what we mean by this. An example of a lone pair going to a pi bond is if I have this Al anion here. So there's a lone pair here with a negative charge. If I take this lone pair, I can put it here and move these electrons to the carbon on the end, and that is giving me a new resonance structure in which I've turned this lone pair here into this pi bond here. An example of having a pi bond to a lone pair is if I had a ketone. I could break this pi bond and move the electrons up to the oxygen to give a resonance structure that looks like this, where there's a negative charge on the oxygen and a positive charge on the carbon. In the final example, we have pi bond to pi bond. That would be something like if I had allyl cation and I could move this pi bond over to the right, giving another resonance structure where the pi bond has just moved locations. So these are the legal moves we can make in resonance. We can go from lone pair to pi bond back to lone pair, or pi bond to pi bond. Now there's a few general guidelines to follow when you're trying to find resonance structures. So the guidelines are: first, when you have a positive charge, you move electrons towards it to stabilize it. So to stabilize a positive charge, move electrons towards it. When you want to stabilize a negative charge, move electrons away from it. Another piece of advice, another guideline, is to take things one step at a time so that you don't miss any intermediate resonance structures. And finally, make sure that you never break octet or whatever the valence is for that particular atom. So for example, for hydrogen, it can't have more than 2 electrons. For carbon, oxygen, nitrogen, you can't have more than 8. So never break octet. So as a couple of examples, say we had this molecule here with a positive charge on the end. Well, we have a positive charge, so we want to move electrons towards it to stabilize it. I'm going to take things one step at a time, and I'm going to take a pi bond and turn it into a pi bond. Now this carbon on the end here, it is positively charged, so it only has 2 hydrogens, so I'm not breaking the octet of carbon by moving this pi bond. So this is a legal move of resonance. So now the positive charge is on the middle. So I've taken just one step. Now I can take a second step where I keep pushing electrons towards this positive charge. And now my positive charge is on the opposite end of where it started. Now an example of stabilizing a negative charge is, let's take that same molecule, but make it an anion. Now we've got a negative charge, so we want to push electrons away. So I'm going to take this lone pair and make it into a pi bond. But this carbon right here has a hydrogen off of it, and so it already has 4 bonds. So by adding that lone pair, we're making a 5th bond. So to not break octet, we're going to at the same time have to break that pi bond. So our intermediate structure is this one here, which has a negative charge on the middle carbon. Now again, we have a negative charge. We're going to keep pushing the electrons away. So the next step would be to push them down. It's the same case that we're going to at the same time have to break that pi bond so that the carbon right here doesn't get too many bonds. And we get a structure very similar to the one up above, except we have a negative charge instead of a positive charge. Now an example of where it's not going to work to move electrons towards or away from a positive or negative charge is the following. Assume we had this molecule right here, where we have an oxygen that's got 2 hydrogens on it, and it's positively charged. That means it must have one lone pair of electrons. Now we have a positive charge, so we might think, great, we want to move these electrons here from this pi bond, which are in the right location to be able to be part of resonance. We want to move them towards that positive charge to stabilize it. So we might start by going up here, and then we're going to figure out, oxygen already has 1, 2, 3, 4, 5, 6, 7, 8 electrons associated with it. And there are no pi bonds to oxygen that we can break to relieve it, to not break its octet. So we can't do that. So we cannot stabilize this positive charge through resonance because oxygen already has a full octet. What we could do as a resonance structure, though, is just to move the pi bonds of this benzene ring around. So a valid resonance structure is the one shown here, which just has the benzene double bonds shown on the opposite sides.